narrative examples is to provide you with sort of a bit of a break between talking specifically about concepts, but also to allow you to think about these technologies in a slightly different way. Rather than me just presenting on a technology and then giving you an example of the technology, the idea behind this presentation format is to give you an example of a problem and then how we can solve it with a specific technology. Because once you understand a problem that something solves, you understand the technology a lot better, rather than describing the technology, for example, going all the way into describing how a wrench works before talking about the need to tighten some nuts. Okay, all sessions in this learning path are going to use the Tailwind Traders fictional company. Now, you don't need to really know a lot about Tailwind Traders other than they've got a central office and they've got branch offices, and those branch offices are spread across cities in multiple countries. Now, even though they're spread across multiple countries, they've got a single Active Directory domain services forest. And branch offices are connected to one another using a single hub and spoke topology, with the head office being the hub and VPNs and direct connections coming in from the spokes. Now, Tailwind Traders has been around a while. That means that they've got a substantial amount of resources on-prem. And they're not going to start, especially in these times, splurging cash on completely transitioning to the cloud. They're going to continue to require their on-prem Active Directory for the foreseeable future, and on-prem Active Directory should be the primary source of identity. What they're going to do, though, is that they're going to adopt technologies in the cloud where it makes sense, and they want to be able to connect to those technologies in the cloud in a hybrid fashion. So let's talk about the Tailwind Traders hybrid strategy. They're a multinational. They've got, let's say that they're in Australia and New Zealand and Singapore. They've got an on-premises deployment. However, that on-premises deployment's been around for a while. They've got aging infrastructure and their infrastructure's running close to capacity. They've got space in a colo facility. They don't want to hire more racks. They've got servers that they've had since 2008 or 2012, and they don't want to go and buy new equipment if they don't have to. However, they're slowly and steadily growing. Not at a rapid rate, just in a nice, slow, steady rate. And rather than buy those extra racks, rather than expand their on-prem capacity, they're sitting there thinking, you know what we might do is we might extend things into the cloud so that the cloud becomes our buffer. And if we know that we need something, well, then maybe we bring it on-prem or maybe we keep it in the cloud. We're going to see how this thing works. So they want to enhance that on-premises deployment with appropriate cloud technologies. What they don't want to do is they don't want to pick up an existing server that's working perfectly well and just shift it to the cloud because a consultant told them that that's an awesome thing to do. Sometimes it is an awesome thing to do, but sometimes that on-prem server that works really well should be kept on-prem. But new servers, well, instead of going out and buying hardware for them, maybe you go and run those in the cloud. So Tailwind Traders is really, and this is the core of this idea of hybrid, looking to achieve an optimal balance between their workloads, existing workloads hosted on-prem, and new workloads hosted in the clouds, or where it makes sense, moving a workload from on-prem to the cloud. In this session, we're going to cover the following topics. We're going to come up with a definition of hybrid cloud. And everybody's kind of got their own one, but we'll work with a functional definition here. We'll talk about a variety of hybrid cloud architectures. There are many, many, many ways to do hybrid cloud. There's certain ones that are reliable. There's certain ones that we know that work, and they've been codified as architectures. We'll talk about the elements that make up most hybrid clouds. We'll talk about the tools that you can use to manage and govern your hybrid cloud. We'll talk about some of the things that you need to think about if you've got data in the hybrid cloud. And we'll also hit some challenges and really reinforce that hybrid cloud or any adoption of technology isn't all upsides. There's other things that you need to consider. There's things that you need to be aware of. And sometimes in these sort of sessions that people can only give you the good bits and they won't say, well, here's some of the drawbacks as well. You've got to understand the balance that you're striving for. So, what is a hybrid cloud? For the perspective of Microsoft Azure, a hybrid cloud is a stable state, not a transitional state, but a stable state where an organization will host some workloads on-prem and other workloads in Azure. So this is an important statement. We're not talking about hybrid as a transitional state. We're not saying that hybrid is the road that you're on between on-prem and the cloud. We're actually saying that hybrid cloud is a destination where you're getting the best of both worlds. In a hybrid cloud environment, you've got resources on-prem, and those resources on-prem are able to communicate securely and seamlessly with resources in the Azure cloud. So what that means is that the communication between the elements of this cloud, be it on-prem or be it in an Azure data center, have secure communication. It's not something where someone can easily go and intercept that communication or interrupt it or modify it. In a hybrid cloud, you have a consistent identity infrastructure for authentication and authorization. Now, what that means is it means that you're not using a separate set of accounts to authenticate against cloud resources compared to the accounts that you use to authenticate on-prem. Now, it might be that you have a single identity provider. Most likely, given that this is Microsoft, it's going to be something like Active Directory. But what you're not doing is you're not doing what used to happen at a place I worked in the 90s, where each system that the staff interacted with required a separate set of login credentials. And people had to keep notebooks around to look up what the credentials were for a particular system that they were interacting with. If they were enrolling students, they looked at one thing. If they were doing faculty finances, they were doing another one. In a hybrid cloud, you've got a consistent identity. If you need to authenticate against a web app on-prem, you use that identity. You use the same identity to authenticate against a database running in the cloud. Now, the other thing about a good hybrid cloud is that you've got a consistent set of tools that allow you to manage on-prem and cloud workloads and infrastructure. What does this mean? It means that, again, you don't need to pull out a different toolbox if your stuff's on-prem compared to the toolbox you pull out if your stuff's in the cloud. In the best of all worlds, you're using a single tool to manage workloads on-prem or in the cloud. And in the best of all worlds, you don't really need to know if the workload's on-prem or in the cloud. You're just using the tool to manage it wherever it is. Now, the other thing and the final thing in this particular definition of hybrid cloud, and there's other definitions out there. This isn't certainly something formalized by something like NIST. It's that you have a consistent set of technologies used to secure your on-prem and cloud resources. So just as I said, you don't have a different toolbox for managing on-prem as opposed to managing the cloud. You have a single toolbox in terms of your security tools to manage or to secure on-premises and cloud resources, that you can assess the security of your resources, or you can be alerted to infiltration or security misconfigurations using a single set of tools for on-prem and cloud, rather than, again, having to go, well, I need to know if there's a security alert I'll look at my cloud security alerts and they're over in this box, and I'll look at my on-prem security alerts and they're over in that box. Okay, so now that we've got that definition out of the way, let's look at one of Tailwind Traders' challenges. So they've currently got Windows Server virtual machine workloads that are dependent on Active Directory domain services, which is fairly common. A lot of people obviously have AD and they've got Windows Server VMs. Now, in this particular case, these workloads are dependent on an Active Directory schema customization, and that this application or these workloads are present at various branch offices. Now, these workloads are running alongside virtualized DCs on aging virtualization host hardware. I mean, maybe they took Windows Server 2012 R2, put Hyper-V on it, and then put a bunch of VMs there. And this hardware is getting near end of life, working for a certain amount of time before you'll start seeing an increasing number of failures. The reality is, for Tailwind Traders, the workers in these particular branch offices still require access to these workloads. One of the things that Tailwind Traders has looked at is they thought, well, could we migrate or centralise this? And because Tailwind Traders is a multinational organisation, it doesn't make sense to move these workloads too far from where they're already currently located. Okay, so with those challenges in mind, what kind of solutions could we use hybrid with? Well, one of the things that we could do is we could connect each Tailwind Traders branch office to Azure using a VPN or ExpressRoute. A VPN, virtual private network, is an encrypted connection that runs over the internet. ExpressRoute is a high-speed fibre optic connection that runs straight over a private link that doesn't cross the internet into an Azure data center. So what Tailwind Traders could do is they could deploy brand new Windows Server IaaS VMs, that's a virtual machine that runs in Azure, and configure those VMs as domain controllers, and then configure a new Active Directory site in the existing domain to represent that Azure data center. They could move those VM workloads from the aging virtual machine hosts out at the branch offices into the Azure virtual networks that have got the IaaS VM domain controllers. So basically what they're doing is they're replicating that infrastructure that exists on-prem at the branch offices and moves it into the cloud. And that's a case where, okay, the aging virtualization infrastructure doesn't need to be replaced, and the virtual machines are still able to interact with that custom schema. Because there's certain situations where people move stuff into the cloud, and unless they replicate those schema changes, they're not going to work with those VM workloads. So let's look at an example hybrid deployment. In this particular image, you can see that we've got the on-prem network, and we've got a connection to a gateway subnet, and on the on-prem network, we've got our Active Directory domain controllers, and that our on-prem network does have a perimeter network that's got a public IP address. Now, the gateway subnet runs through to the application subnet. There's a separate subnet on that virtual network that hosts the domain controllers. And those domain controllers are able to replicate and be part of the same domain or the same forest, depending on how you configure it, as the domain controllers on-prem. And if they're part of the same forest, they can have exactly the same custom schema extensions, just replicate as part of that forest. There's no need to come up with a separate infrastructure and then modify the structure of the schema in the cloud. Or at some point you could do that. It just depends. But that's one particular hybrid scenario or hybrid solution for that specific set of circumstances. And as we'll look at in future sessions, if, for example, those workloads did have an Active Directory dependency, but they didn't require the custom schema extensions, well then maybe another option would be appropriate. Maybe we could domain join them to an Azure Active Directory Domain Services domain, which allows you to virtualize Domain Controller as a service. And we'll get into that sort of situation in the next session in this virtual training day. So let's talk about hybrid cloud architectures. Microsoft publishes and updates hybrid cloud architectures on docs.microsoft.com. To understand what a hybrid cloud architecture is, it's sort of a best practice solution for a specific problem that you might have. It gives you a reference way of solving the problem. It doesn't mean that's the only way of solving the problem, but what it does is it gives you a look. If you've got this particular scenario, this is how you can take an off-the-shelf solution and start to tinker with it by yourself. And in the slide is a screenshot of the hybrid cloud architectures page. Inclusive in the existing hybrid cloud architectures, and more are being added all the time, we have architectures such as how to manage configurations for Azure Arc enabled servers, how to use Azure automation in a hybrid cloud environment, how you can use Azure file shares in a hybrid cloud environment, how to use Azure automation update management to manage your updates, how to use hybrid file services so that you've got file servers on-prem and in the cloud, how to use hybrid security monitoring with Azure Security Center and Azure Sentinel, how you can run containers in a hybrid environment, how you can extend on-premises Active Directory Federation services through to Azure, how you can manage hybrid cloud workloads using Windows Admin Center, that is, manage your workloads on-prem and in the cloud, how you can implement a hub-spoke network topology with the cloud, given your existing network infrastructure, how you can use Azure Arc hybrid management and deployment for your Kubernetes clusters, how you can connect an on-prem network to Azure, that one's obviously a fairly basic and straightforward one, how you can scale your on-prem workloads into the cloud, how you can integrate your on-premises AD domains with Azure Active Directory, and how you can configure Active Directory domain services resource forests, that is, where they host resources, not accounts, in Azure. Okay, so let's get on to the next challenge. And in this challenge, when we're thinking about how hybrid works, we're looking at web applications. So Tailwind Traders has branch office perimeter networks that host web applications in multiple countries that they wish to decommission. Now, I'm sure you're aware of this, but if you've kind of forgotten how this works, basically a lot of organizations have got perimeter networks, sometimes called DMZs, that sit there and they host web applications, and people connect over the internet to those web applications, and the web applications do something related to the business. Now, perimeter networks are expensive to maintain, not just because of the equipment, but the moment you basically in some way allow inbound traffic to your network, even if it's sitting on a perimeter network, you've got a whole lot of questions and you've got a whole lot of decisions that you need to make about security. So one of the other things that Tailwind Traders knows is that several weeks a year, when they run an online retail campaign, those applications can simply get overwhelmed with traffic and fail. And this annoys customers, it annoys management, and it of course annoys IT because they get blamed for it all. So one of the things that Tailwind Traders wants to do is they want to make sure that during those periods where they're going to be hit by massive traffic, they can cope with it. But what they don't want to do is they don't want to go and put in place massive infrastructure to deal with something that's only a problem less than 5% of the year. The other thing that they want to do is they want to put in OWASP filtering and distributed denial of service protection for their web apps. And they don't want to be sitting there managing complex perimeter network firewall systems. One of the things that they've learned is that occasionally people would run denial of service attacks against their applications during one of these retail campaigns. which meant that the websites went down faster. So what can they do about that? Well, solutions exist within hybrid. What Tailwind traders can do is that they can move all of those perimeter network web applications and host them on networks in Azure. In fact, Azure and the cloud is really well suited to the migration of perimeter network applications. Instead of hosting the perimeter network adjacent to your on-premises network, what you do is you move your perimeter network up to the cloud and you allow the cloud to handle all of that. And then you've got a VPN or an ExpressRoute connection up to that network itself. Remember, if you've put it in a perimeter network, it is an externally facing application. So it's really suited to running in the cloud. Now, you can protect applications from attacks that are on the OWASP top 10 list. So what's the OWASP? It's basically a list of the top most common types of attacks that are run against web applications. And you can also protect against distributed denial of services, basically by putting in place Azure technologies such as distributed denial of service protection and web application firewall. If you go and put these web apps in the cloud is purpose-built to allow you to scale up and down as your traffic fluctuates. You can configure a web app so that if it starts to hit a certain number of requests, bang, it adds more instances to that, or it adds more powerful instances to that so that it handles the traffic. And as the traffic disappears, the web app shrinks itself back down so that it's running in the most efficient and, more importantly, the cheapest way possible. So let's talk about the elements of a hybrid cloud solution. Your hybrid cloud solution needs to have management, identity, networking, security, and fabric when you think about it. So from the management perspective, make sure you've got a consistent set of management tools to manage on-prem and cloud workloads. Now, when we're talking about Windows Server heterogeneous networks, that is, that you might have some Linux there, you'll have already figured out a way to manage your Windows Server and your Linux workloads on-prem. What you don't want to have to do is pick up a third set of tools to manage your workloads in the cloud. What you want to do is you want to use the same set of tools to manage your workloads on-prem and in the cloud. So with Windows Server, you can use Windows Admin Center to actually manage on-prem and Azure workloads. You can use Azure Arc to manage the configuration of all your Windows servers and your Linux servers on-prem or in the cloud. For identity, you want to use a single identity provider for authentication and authorization. Now, that might be straightforward, bog standard Active Directory that you run on-prem, or you might move everything to Azure Active Directory. If you've got Office 365, you're already using Azure Active Directory because what's happening is that you've already got identity synchronization where people are logging in to Office 365 using their on-prem accounts that are replicated up from your on-prem domain controllers. Your networking needs to be secure and reliable. You need to have a way of making sure that you can connect your on-prem network to Azure. What you don't want to do is you don't want to have everything on your on-prem network initiating its own independent connection through to the cloud. You want to set up a secure pipe, be that an ExpressRoute connection or a VPN connection to allow that communication to occur. And it needs to be reliable. So you need something that's actually supported by the cloud provider. You need to have a single set of tools to monitor and respond to suspicious activity. Now, luckily, you've got Azure Security Center and Azure Sentinel, and these can be used to ingest security data and analyze security data from on-prem and cloud resources so that you can go into Azure Security Center or into Azure Sentinel and you can actually look at one console and you can see security telemetry from your on-prem and your cloud resources. The other thing is that you need to make sure your on-premises fabric is managed and maintained as consistently as the cloud fabric. Now, this is a bit unusual when you're thinking about hybrid, but this is more an exploration of where Microsoft is going. And what I mean by that is in the public cloud, you don't worry about managing the fabric. And what I mean is, for example, if you're running a web application or if you're running a database on platform as a service, you don't actually worry about managing the underlying infrastructure. And with products such as Azure Stack HCI, you can actually have your on-prem infrastructure managed by Microsoft. Let's talk about that a bit more. So the Azure elements of a hybrid cloud solution. For management, you can use the Azure portal and Azure Arc, the Azure CLI and Windows Admin Center. So you can use the Azure portal, especially when you've got Azure Arc configured, to do management of on-prem resources. For identity, you've got a variety of options that come with an Azure hybrid cloud solution. You can use Azure AD. You can use Azure Active Directory Domain Services, and you can use Azure AD Connect. And that's all without getting into complex topics such as identity federation. For networking, you've got Azure VPN and Azure ExpressRoute as the products that you use to connect your on-premises resources to Azure. What you don't need to do is you don't need to go, wow, how am I going to connect my on-prem to the cloud? I know what I'll do. I'll spin up my own VPN appliance in the cloud, and I'll spin up a VPN appliance on-prem, and I'll connect them that way. No, well, we've got VPN as a service with Azure. So you're just connecting into that VPN as a service. For security, as I mentioned, you can use Azure Sentinel, which is a security incident and event management solution, or a SIEM, or a SIM, depending on how you say it. You've also got Azure Security Center. So Azure Sentinel is a way of looking at all of your events and then running queries using Jupyter notebooks against those to find suspicious activity. Azure Security Center is sort of a pre-built set of configuration alerts and best practices and ways of assessing your infrastructure. So if you want to know that if you're compliant with a particular security standard, such as PCI DSS, you can use Azure Security Center to do that. And in terms of fabric, there is an increasing number of products available from Microsoft in the Azure Stack range. You've got Azure Stack HCI. Now, what does Azure Stack HCI do? Well, instead of you managing your entire virtualization infrastructure all yourself, where you're installing new Hyper-V servers and you're managing and configuring those Hyper-V servers, what you do with Azure Stack HCI is it's basically a box or a bunch of boxes that you put in your data center where Microsoft is responsible for managing all of the configuration of that infrastructure, and all you worry about managing is the actual virtual machines themselves. And then you've got Azure Stack Edge, which instead of just doing the VMs, which you do on Azure Stack HCI, Azure Stack Edge allows you to run those web apps and all of those Azure services on-prem. So if you're in a situation or a disconnected data center situation, let's say that you're in a submarine or on a cruise ship where you still need to run the sorts of applications that you'd run on platform as a service in the cloud, well, you can run them on-prem. But in that case, Microsoft is responsible managing the infrastructure and you're just responsible for managing the applications. So let's come back to a challenge for Tailwind traders. So Tailwind traders needs to keep a large number of VMs on-prem, but has noticed that maintaining the virtualization fabric that hosts those virtual machines is increasingly challenging. Now, downtime occasionally occurs because the process of applying operating system updates, device driver updates, and firmware updates is a complicated task for hyper-converged virtualization infrastructure. Okay, so how do they solve that? Well, let's go back to what we talked about before. Azure Stack HCI would provide Tailwind traders with an option of a fully managed virtualization infrastructure, where Tailwind traders' IT operations only has to worry about virtual machine workloads and doesn't have to worry about managing and maintaining the infrastructure that supports those workloads. Now, many organizations have already started the move towards a hybrid posture. And as I have mentioned earlier in this presentation, the thing about hybrid when you do it properly is that it improves, it enhances your on-prem deployment. As I said, lots of organizations have already got hybrid cloud. If you've got M365 technologies such as Exchange Online, Teams, or are already using Azure web applications, you're already hybrid. So It's already natural for most organizations to actually understand that they already have a hybrid deployment. And you can be incremental about a hybrid deployment. One of the things that people get wrong about the cloud is they get this idea in their head that it's an all or nothing proposition. You can be hybrid. You can have a little bit of cloud or you can have a lot of cloud depending on what you need. What your organization should always do is choose the appropriate cloud technologies that are going to make your organization successful while still keeping those things on premises that you need to keep on premises. So another challenge. Now, Tailwind traders looked at their infrastructure and they did an audit of their Windows Server and Linux workloads, both on-prem and in the cloud, and found that 30% didn't have the most recent software updates installed. Because Tailwind Traders has multiple branch offices spread across multiple geographies, it can be very difficult to make sure that absolutely everything is kept up to date. It depends who owns the workload. Sometimes in organisations that are very geographically dispersed, you get some workloads that are absolutely kept up to date and other workloads that are basically left without being patched. I can't tell you how many organisations I've gone into where the first thing I do is just check, have you got software updates done? And it's usually not just 30% of server workloads that don't have the most recent updates installed. So one way of Tailwind traders addressing this problem, a hybrid way of Tailwind traders addressing this problem, is using Azure Automation Update Management. And this is another way of thinking about how the cloud or how the hybrid cloud can work in your environment. Because in a hybrid solution, what you can do is you can have your management layer that does all of your monitoring running in the cloud, and you can keep all of your workloads still on-prem. With Azure Automation Update Management, as you can see in this image, you can have Linux and Windows workloads on-prem, as well as workloads running in the cloud, and that you can have one pane of glass, which just basically means one console, to manage updates and compliance for all of those operating systems. So looking at Tailwind Traders' next challenge. As with all of us, they've got to make sure that they're compliant with particular standards. And recently, they took a long time and a lot of money auditing their configuration of their Windows Server and their Linux workloads to determine if they had drifted from a baseline security configuration that ensured that they were compliant with a bunch of standards such as ISO 27001 or PCI DSS 3.2.1. So how can hybrid cloud help with this? The hybrid solution for this problem is that by using Azure Arc, by using Azure Policy, by using Azure Security Center, Tailwind Traders is able to basically perform an audit on the configuration of workloads and determine whether or not they are compliant with a particular set of security standards. They can then remediate those workloads and ensure that they are compliant. So it's possible in a hybrid cloud scenario to centrally assess the compliance of your workloads. That's something, of course, you can do on-prem, but again, it comes back to this idea of when you adopt a hybrid cloud, that you sort of sit there and you go, you know what we can do? We can actually have our management layer in the cloud where we go and assess all of our workloads, and then we go in and drill down and fix those non-compliant workloads. Now, in terms of hybrid cloud management and governance, Azure Arc and Azure Policy can be used to ensure your hybrid workloads are configured in a specific manner. For example, in a later session, you will see how it's possible to use Azure Arc and Azure Policy to determine whether or not Windows Server VMs are configured to automatically update their anti-malware definitions. You can use role-based access control in a hybrid environment to ensure that only authorized users are able to perform specific administrative actions. Role-based access control is assigning permissions to a specific scope. And in a hybrid environment, you can be very detailed about your scope. You can put your scope as an individual virtual machine or all virtual machines that are running in your environment. Or you can do it to a group of virtual machines or to an app or a group of apps or so on and so forth. Tagging you can use to find workloads related to a specific project. One of the other great advantages of a hybrid cloud is it allows you to simply organize all of your workloads a lot easier. If you've just got an on-prem environment where you've got virtual machines sitting on hypervisors every which way and every which branch office that you've got, it can be very difficult to work out who those workloads belong to. In fact, there has been research that's done that suggests that up to 30% of virtual machines that are running in the world are actually zombie workloads. That is, that they're workloads that don't belong to anybody, that they were spun up and forgotten about. Tagging's really great. And through Azure, by integrating it with Azure Arc in your hybrid environment, you can start to apply tags to all of your workloads, both on-prem and in the cloud, so that you can do a quick search to find where a particular workload works. Now, there's other products that do this, but this is another way that hybrid can make your on-premises infrastructure better. Okay, so another challenge for Tailwind traders. Like everybody, they've got file servers. In fact, file servers are the most common type of server in the world. And file servers have a problem. People keep creating new files, and they very rarely delete old ones, which means file servers tend to run out of space. And what we all do as IT pros, as administrators, is often we sit there and you go, well, file servers run out of space again. What are we going to do? We need to go and muck out. We need to go and remove old files and put them into long-term storage and just hope that no one's going to ask for those files at some point in future. Because occasionally you get someone saying, oh, look, I left a particular file on a particular directory 3 years ago and I can't find it. Can you go and find that for me because we need it for this new project? File share replication also can cause a lot of problems. Anybody that's implemented DFS on their WAN has found that certain branch offices don't get updated, that there's conflicts, and there's always a whole lot of problems. Well, there is a solution within a hybrid environment, and that's called Azure File Sync. We'll go into Azure File Sync in more detail in a later session, but the idea with Azure File Sync is that you turn it on for your file shares, and then your file shares are automatically replicated up to the cloud. And the cloud keeps a copy of everything. But it's a bit like OneDrive, where with OneDrive, you can basically have you can say, keep this in the cloud, and all it does on-prem is put a little placeholder, and then when you click on the placeholder, it replicates it down from the cloud. Well, Azure File Sync's sort of like that. And instead of it being like OneDrive, which is just for your client, Azure File Sync works for your server. Anyway, you'll learn more about that in a later session. If Tailwind traders implements Azure File Sync, they can turn on cloud tiering, and they could turn on Azure File Sync to automatically tier any file that hasn't been accessed for 30 days. So with OneDrive, you've got to do it manually. You've got to say, hey, let's put this folder up into the cloud. With Azure File Sync, it'll say, hey, you haven't touched this for 30 days. Bang, I'm automatically going to go and tier that for you. And if you're a user accessing that file on the file share, you've got no idea whether or not it's been tiered or not. But if you try and open it, what happens is it syncs back down from the cloud and then opens normally. You can also have additional file servers so that file servers all across Tailwind Traders' deployment across multiple countries can all have a copy of the same file share. You have a source of truth sitting in the cloud that holds everything. Because remember, cloud file shares can be as big as you want. Your on-prem file shares might only be a couple of 100 gigabytes in size. You can also configure the file share to be backed up every day. And instead of doing the backup on-prem, you just run the backup in the cloud. And if someone deletes a file, well, you come back and you recover it in the cloud, and then that recovered file is available to all instances of that file share. In terms of data in the hybrid cloud, think about it this way. One of the ways that hybrid cloud can really make things better for you is that storage in the cloud is cheap and functionally limitless. I mean, not in reality limitless because you can't put an infinite amount of data up there. But the cloud can act as a store for as much data as you can throw at it. You can put it on colder storage, slower storage, and when you put it on slower storage, it's cheaper to keep, but you can keep a lot of it there so that you can access it when you need to. It might take a little longer to pull down, but you can keep as much data as you want in the cloud. That's a lot more efficient than sort of the old way we used to do it, where we put it on tape and then ship the tape off to an archive facility. And Azure File Sync can be automatically configured to tier cold data that no one's using anymore, to an Azure file share, so it's easy and cheap to store. Okay, so we're going to finish this introductory session with a set of best practices and some challenges. So let's start with the best practices. Make sure you're using a consistent set of management tools for your on-prem and cloud workloads. You don't want to have to become an expert in lots of different tools to be able to manage your hybrid environment. You should manage your hybrid environment in a consistent manner. Make sure that consistent security policies are applied to hybrid workloads. It shouldn't be that your workloads in the cloud are really secure and your workloads on-prem are any which way but loose. You should make sure that the same security policies apply to on-prem and to the cloud, that your Linux machines are configured in a certain way, a certain secure manner on-prem and in the cloud, and your Windows machines are configured in a certain way that's secure on-prem and in the cloud. Make sure that backup and disaster recovery is configured for all of your workloads. Don't assume that because you deploy something in the cloud that it's automatically being backed up. It's a big mistake a lot of people make. You know when it's on-prem that you've got to back it up. Why? Because you've learnt the hard way that if you don't back it up on-prem and it fails, you've got no other options. But the same thing can apply in the cloud. And we'll have a session later on about talking about backing up and disaster recovery in hybrid environments. Make sure you track workload costs on-prem and in the cloud. There's tools that allow you to do it in the cloud, but you should also be aware of what your costs are on-prem. When someone asks you how much it costs to run a server or a virtual machine workload on-prem, you should have a ballpark figure in mind to provide them with. You just can't shrug your shoulders and say, I don't know, because then someone will come back and say, well, let's move everything to the cloud, because if you don't know how much it costs on-prem, maybe it's cheaper in the cloud. And maybe it is, but maybe it's not. You need to know how expensive it is to run things on-prem so that you can make a comparison as to how expensive it is to run things in the cloud. Finally, there are some challenges that come with running a hybrid cloud. When adopting a hybrid cloud, make sure that the environment doesn't become so complicated that you can't manage it. There's a thing called cloud sprawl. That is that people get to the cloud and suddenly they can find that they can deploy as much stuff as they want. And that's great until you need to keep track of it all. So you make sure that you limit what can be deployed so that you can maintain it, you can manage it, and you've got a good map of what you've actually got. Make sure that workloads are going to be hosted in the appropriate location from the perspective of cost, governance, and compliance. Don't be like some people who decide, oh, you know what, I'm going to go and put that data in that VM, and I'm going to run that VM in that data center overseas, only to find out that the data within that virtual machine is only allowed to be kept within the country. And that by moving it to a virtual machine that's hosted in the cloud in a data center overseas, you've actually broken some local laws. Now, the other thing to keep in mind, and this is very important when people talk about how moving to the cloud makes things cheaper if you do certain things. Migrating a virtual machine is only the first step in migrating a workload to the cloud. And we do have a completely separate virtual training day on cloud migration. It's eventually necessary to migrate the application to a platform as a service to take full advantage of what the cloud offers. That means instead of running a monolithic application sitting in a VM, you eventually want to get to the stage where it's running as an Azure web app or as a container or as a set of functions or serverless. Anyway, thank you very much for your attention. Okay, in that session, we went through an overview of how hybrid cloud works. We're going to take a break for 10 minutes, and then we're going to get into how hybrid network infrastructure and identity works. Hope to see you there.
Welcome back from the break. In this next module, you'll learn about identity and network architectures in a hybrid environment. This is important for ensuring that network traffic between on-premises and cloud workloads takes an optimal path and avoids the public internet when required. We'll also explore how to simplify your network traffic between different office locations. And finally, you'll learn about the options for using your on-premises Active Directory identity platform to allow access to resources and workloads inside Microsoft Azure. Let's get started. Welcome to Hybrid Cloud Identity and Networking. My name is Sonia Cuff and I'm a Senior Cloud Advocate at Microsoft. In this session, I'll explain how an organization can configure both the networking and the identity components of their hybrid deployment. All of the sessions in this learning path use Tailwind Traders as our fictional customer. This company has a central office and branch offices spread across cities in multiple geographies. Now they use a single Active Directory forest and their branch offices are connected to one another using a basic hub and spoke topology, with the head office being the hub. There are some occasional direct connections via VPN between specific branches, but these have been deployed over time on a bit of an ad hoc basis. And the exact configuration of this whole networking topology isn't really precisely documented. Tailwind Traders will continue to deploy a substantial amount of resources on premises. They have business requirements for keeping some data on-prem, but they'll also continue to grow with their Azure deployment and moving some workloads or maybe even adding some new ones inside the cloud. For the foreseeable future, they need to keep their on-premises Active Directory as their primary source of identity. From a networking perspective, not only do they need to ensure that they have easy connectivity between their branches and their head office into Azure, but also between each of their different branch offices with one another, they need to make sure that those network connections are secure and reliable as possible. So, which hybrid networking and identity model should Tailwind Traders use? There's more than one way to configure this, so let's jump in and have a look at your options. First, it's important to start with a list of the business requirements. So the questions Tailwind Traders need to answer include things like how do they connect their branch offices to resources and workloads in Azure without making those cloud resources available to the public internet. So even though they're in Azure, we don't want anyone on the internet to be able to connect to those cloud workloads. How does Tailwind Traders ensure that network traffic from their specific branch offices to specific workloads and resources in Azure doesn't cross the public internet? So as well as not having those resources open to the internet, they don't want their own network traffic from their branches into Azure to go anywhere near the public internet either. And that's a specific requirement at some of their branch locations. Next, how can Tailwind Traders simplify its network topology when routing traffic between its branch offices? Now that they've experienced a bit of growth and they're in a bit of a mess as people have joined a company and created these environments and maybe even left the company, it's time to consolidate and simplify this network topology across all of their locations. And last but not least, how can Tailwind Traders restrict access to resources and workloads inside their Azure data centers using their on-premises identities? They've got a significant amount of investment in capital in the user accounts and identities that they've been building up on-prem over time. So they want to keep using that, and they may have specific, say, even line of business applications that require that kind of identity to be used to authenticate into the applications. To help answer those, we're going to look at a couple of different networking technologies and how you can set up a hybrid structure for your identity requirements. Today we'll look at Azure VPN, Azure ExpressRoute, Azure Virtual WAN, and a hybrid identity scenario. Starting with Azure VPN. You may be familiar with configuring a VPN on a network device so that remote workers can log in securely via a tunneled VPN network connection, for example. In this case, what we're doing is we want to create a VPN connection into Azure. You're still going to require a gateway device on premises in your physical location. But Microsoft manages this VPN connection and guarantees 99.9% availability for the VPN gateway service in Azure at the Azure end. It's important to remember that there's no guarantee on the reliability of the connection to that gateway in Azure as it crosses the internet. So there are a significant number of networking components that are outside of Microsoft's control, which could affect that VPN reliability. That's just how networks work. The maximum bandwidth per VPN connection is up to 1 gigabit per second, and it may be necessary to have multiple connections depending on the size of your environments. With this VPN gateway, we have encrypted traffic passing across the public internet. So we're not creating any physical private connections, but we are doing end-to-end encryption on the traffic that's going across the public internet. From an architecture perspective, we've built up a complex picture here of how you could connect this all together. So for Tailwind traders, we have their on-premises environment with their gateway appliance that is going to be their physical end of the VPN connection. Over in Azure, we create an Azure virtual network that has different subnets in it. And so we have a gateway subnet, and that's where the Azure end of that VPN connection sits. Inside our gateway subnet, we have our VPN gateway. Now within that Azure virtual network, we can also create different subnets with network security groups that manage traffic into things like individual virtual machines, or contain things like Azure Bastion for secure remote connectivity to a VM without needing an RDP port open. Now Tailwind traders also have an Azure Stack implementation. So they have a virtual network for Azure Stack with a VPN gateway that passes through public virtual IP addresses and connects through to those same resources that they have in Azure, those virtual machines. So when we're talking about an Azure VPN gateway, it includes the following pieces. We have that virtual network gateway that sits inside Azure, which is a virtual VPN appliance for the virtual network. And this is what routes the encrypted traffic from the on-premises network into the Azure virtual network. Then we have the local network gateway. So that's your on-prem VPN appliance from whichever vendor you choose. And that routes the traffic from the on-prem network into Azure. Now between these two, we have the connection itself. And the connection is configured with different properties like the connection type and a key that is shared with the on-premises VPN appliance for doing the encryption of that traffic. It's important to make sure that your local network gateway supports the connection type that you've configured. And finally, the gateway subnet. So that was the special subnet inside our Azure virtual network that hosts that Azure VPN gateway. Let's look at that a little bit more. The Azure VPN gateway subnets host the IP addresses that the virtual network gateway virtual machines and services use. So we want to protect this subnet. We don't want to deploy any other workloads into this gateway subnet, and we have to name it gateway subnet, all one word, for it to function as this VPN gateway. It's recommended that we use a /26, 27 or 28 subnet, and that we don't apply a network security group to this gateway subnet. Next, I will show you a demo of how we can configure this through the Azure portal and add an Azure VPN, but it is possible to create this gateway subnet through PowerShell with the PowerShell command add-az virtual network subnet config, where we give it that gateway subnet name and the address range. You've learnt about the different components of an Azure VPN, so let's go and see what it's like to go into Azure and create one of these. In this demo, we'll look at how to configure a VPN to Azure using the built-in functionality on Windows Server. We've got a Windows Server here, computer name Hybrid Melbourne WAC. So this is a Windows Admin Center instance that we've created on one of our Windows servers. We need to start by connecting this to Azure. So under Azure Hybrid Services, we want to register this instance of Windows Admin Center. It assumes we already have an Azure account, or if we don't, we could click on the link to create one. And it gives us a code to go and copy and a website to paste that copy code into. So we'll add that in and then sign into our Azure account. We can verify which Azure Active Directory tenancy we're connecting to, and it will create a special Azure Active Directory application to allow us to interact with Azure Active Directory. We need to now sign into Azure with an account that has permission to register an application within that Azure Active Directory instance. Once we accept that, now this Windows Admin Center instance is registered within Azure. Inside the Azure portal, I'm going to a virtual network that I've already configured, and I want to add a gateway subnet to that virtual network. This will be what our VPN connection connects to. I'll give it a subnet address range of 172.16.1.0 with a /24. So that gives me 251 possible IP addresses that I can use within this subnet because Azure reserves 5 of them for its use. Don't need to change anything else, and we'll just get that gateway subnet added. So back in our Windows Admin Center, when we go down to Networks, we want to add an Azure Network Adapter. It's picked up the subscription from my logged in user. I'll select a location for it and the virtual network that I'm connecting to. It fills in that gateway subnet address based on what we created inside that virtual network. And then the gateway SKU is just the size of the gateway that we want. And the different SKU sizes inside this have different capacities and capabilities. Now I need to add the client address space, and I'm going to choose 172.16.2.0, which is adjacent to that other 1.0 address that we had before. And then I just need to click Create. This submits the creation to Azure. It will go and configure a VPN device in Azure, and it will configure the VPN connection on this Windows server. So you can see that it's automating a lot of the process. We haven't had to go into different places and configure things manually. This little wizard, now that we've got our subnet set up, is going to go and do the VPN configuration on both sides of the equation for us. You might think that going to the cloud means putting all of your workloads in the cloud, but there are some business decisions that you have to make based on your particular scenarios. What kind of data are you dealing with? Are there any regulations or compliance around that data, how it's stored and how it can be transferred? And those kind of business requirements influence the design decisions you make about the types of traffic you're happy with traversing the public internet, whether you need to investigate using an Azure ExpressRoute connection, or whether some of the data, the applications, and the traffic to that has to remain on premises. If you do need a dedicated line to Azure that won't go over the public internet, you can look at Azure ExpressRoute as an option. Now that connection can be provisioned up to 10 gigabits per second, depending on the provider who's providing this connection. And it can support dynamic scaling of bandwidth So you're not always paying for the largest amount of bandwidth you think you might need. You can scale up when you need it. Now, again, this does depend on the capabilities offered by the ExpressRoute provider in your local area. But the key point is that this traffic between you and Azure via this ExpressRoute connection will not pass across the public internet. And because of that, you get this benefit of a 99.9% availability service level agreement of this entire connection. Remember, that's different to the VPN, where Microsoft was only guaranteeing their VPN gateway at their end. That all sounds pretty good, but there are a few considerations with Azure ExpressRoute. For one, it's not available in all locations, so you're more likely to find it in some of the major cities, for example. The architecture itself can be quite complex to configure, and you do have to deal with a third-party connectivity provider. So they are the ones who are provisioning this network for you to use. You also need some pretty high bandwidth networking equipment on your on-premises sites. I did warn you that the ExpressRoute architecture was a little bit more complicated, so let's break it down. To start with, we have our on-premises network. So that's just your standard office location with your VPN appliance as your gateway. Then you have the ExpressRoute circuit itself. So this is provisioned by your provider, and it's a layer 2 or layer 3 network circuit. It joins your on-prem network with Azure through the edge routers. And those edge routers are hardware that is provided by and managed by the connectivity provider. So you have local edge routers on the on-premises side of your network, and then you have the Microsoft edge routers, 2 routers in an active, highly available configuration. You've then got your Azure Virtual Network, and we have a gateway subnet again, but this time instead of having a VPN gateway, we've got our ExpressRoute gateway connection in that gateway subnet, and then different network subnets for your web application and those virtual machines, business applications, for example, and your data storage that are individually protected by network security groups. One of the challenges around a hybrid network deployment will be determining how to route traffic between offices and whether or not each office requires its own independent VPN or ExpressRoute connection into Azure. So this leads us in to look at Azure Virtual WAN, which might solve both problems. So Tailwind traders needs to ask whether their on-premises offices are in multiple regions. Have they deployed resources into multiple Azure regions? Whether each on-prem site should have individual connectivity to Azure, and whether or not those sites need VPN or ExpressRoute connections into each Azure region. You can start to see how all of these different questions and challenges and individual business requirements help you formulate the decisions you make about how this hybrid network topology is going to be configured. With Azure Virtual WAN, we can provide connectivity between 2 of your different physical on-prem branches through Azure itself. This gives us an automatic site-to-site configuration and connectivity between these on-prem sites and an Azure hub. In essence, it gives us an automated spoke setup and configuration when we step through the processes, and a built-in Azure dashboard to give us some troubleshooting insights and view our connectivity on a larger scale. It's important to know with Azure Virtual WAN, you can have up to 1,000 connections per virtual hub, but each connection has 2 tunnels in an active configuration. So it has 2 network tunnels going all the time that your traffic is going to be split between, giving us a level of redundancy, but it means that we don't have a secondary connection that's sitting there dormant, not being used. Also, our on-premises VPN devices can connect to multiple Azure Virtual WAN hubs. We take a look at the Azure Virtual WAN architecture. You can see that we've got the Virtual WAN inside Azure, in essence being our hub and our hub and spoke topology. And our spokes can be anything from our physical on-premises branches through site-to-site connection. Those branches could be connected via ExpressRoute, and we could also have remote users with individual connections from their devices in a point-to-site VPN configuration. Through those, we also connect to our different virtual networks inside Azure, and then all of these different endpoints can communicate with each other. It's time for another demo, so let's jump into the Azure portal and look at how to set up an Azure Virtual WAN. Instead of using a traditional network hub and spoke topology, we're going to use VPN connections from each of our branch site offices into Azure, and then we use Azure as the backbone to connect those sites to each other. This removes the reliance on your one hub site, because if that goes down, it could potentially take down communications from your branch sites to each other. Inside the Azure portal, we'll start in the marketplace and search for Virtual WAN. So it's Microsoft's Virtual WAN offering here that we need to go and create. This becomes the container for all of our network connections. Now we have the standard options here when you're creating any resource in Azure, including which subscription they're being placed in, which resource group, and I've got one I've already created, and then the location of that resource group. So we'll go and change that one to East US. I'm going to give it a name. And here I get to choose what type of virtual WAN. There's two types, standard and basic. Now, standard allows for a wider range of connectivity options than basic does, and that includes things like ExpressRoute and user VPNs, known as point-to-site VPNs. The basic type for a virtual WAN only supports site-to-site VPN connections, but it's priced cheaper. We'll leave it as standard for the demo. It'll validate against any Azure policies, and it will go and create that virtual WAN resource for us. Now, I've sped that up. It might not take quite so quickly, but I figured you didn't want to sit and wait for it to complete. Inside the virtual WAN itself, we'll start by creating a virtual hub. So this is your Microsoft managed virtual network, and it contains various service endpoints to allow connectivity. Just note that you can only have one of these hubs per Azure region. With this network topology, your site-to-site connections come into this hub, not into VPN gateways on any individual Azure virtual networks where you have your resources. Again, because we're creating a new Azure resource, we get to pick things like the region. It's given us a default subscription and resource group that we were already in for the virtual WAN. And then we get to put in the particular endpoint connection types that we need. So we'll start with a site-to-site VPN gateway. This allows your hub to have your site-based VPN connections coming into it. And when we create this site-to-site VPN gateway, it's going to ask us for the gateway scale units. Now this is the maximum total throughput of this VPN gateway. And it always gives us 2 instances for redundancy, but here we've got a maximum of 500 megabits per second of throughput. So you just need to work out this number based on the number of branch sites that you have and their maximum throughputs. For this demo, we're not going to create point-to-site or ExpressRoute connections, and we don't need to tag it, so we'll go ahead and create it. Again, it'll validate against Azure policy, and there is a warning down the bottom to say that this will take half an hour. I'll speed that up for you so you don't have to wait. So now our deployment has been created. We go and have a look at that hub resource that we've just created. And then we can go back to our virtual WAN and we can see this alpha hub listed. Once we have our hub, we're going to create a VPN site connection. This is the Azure side of the site-to-site connection from one of your branch offices. Again, because it's an Azure resource, we need to put the region in. And we want the region where that branch site office is going to be connecting in from, the closest Azure region to that physical location of our on-premises office. I'll create one from Melbourne, Australia, and add in the device vendor name of the VPN appliance. Next, you can turn on Border Gateway Protocol, or you can specify the private address space of that branch site office. Border Gateway Protocol offers dynamic routing, but your on-premises firewall needs to support it. So to keep it simple for this demo, we'll just specify the on-premises private address space of that office. And we want it to connect that hub resource that we just created. I'm going to enter the link name, the internet provider name, and the speed of that particular branch link, and the IP address of that on-premises gateway device. Let's review and create that. And now we have this VPN site set up, so the Azure side of that Melbourne VPN connection. And I can go into Melbourne now, and under these VPN site-to-site connections, I could download the VPN config if I wanted to then go and set up the VPN gateway on premises. I'm going to go and set up a second site though. So let's get Sydney connected in. Again, putting in the name and the vendor of the firewall appliance that's there, creating an address space for it, and connecting it to that same Alpha hub that Melbourne is connected to. We'll put in a link name, the provider name, the speed, and the IP address of that device in Sydney, and go ahead and create that resource. So now we've got a second site in here, and we can see all the details of that. And if we go back under our virtual WAN and look at our VPN sites, again, we can download the VPN config. So that's going to give us all the information for configuring the on-premises side of these firewalls. In JSON format, you can see that it's got all the information in there about the VPN connections that we need to configure on those devices. So far, we've connected two sites, Melbourne and Sydney, to each other through our hub. Now, if you wanted to create individual devices to connect using a point-to-site VPN, you could use this create user VPN configuration here and add those kind of point-to-site VPNs. We won't do that for the demo, but instead we'll look at adding an Azure Virtual Network connection. So if you have virtual networks in Azure that have got cloud resources in them and you want those sites to connect, we can add the Azure Virtual Network into the hub so that Melbourne and Sydney can connect to these resources in the cloud too. Add a new virtual network connection and connect it to our hub, and again choose a subscription and a resource group, and connect it to our VNet Alpha, our virtual network that already exists inside Azure with some resources in it. Next, you do have the capability to build some different routing tables and configure different static routes, for example, for more complex networks. We don't need to do that here, so we'll just use a default route table, and we'll create this virtual network connection. Let's go and add another one. We'll call this one Beta, and we'll pick the same hub to connect to. But this resource group and virtual network is in maybe a different Azure data center, and we'll add it to the same route table. Okay, so now we've got two Azure virtual networks connected to our hub with our two sites, and they're all routing with each other via this hub and spoke topology, all inside Azure. Once we have our networking topology figured out, how do we handle identity? If we've got user accounts sitting inside Active Directory in our Windows server on premises, we have a number of options for how we can configure our Azure resources to be able to use those identities. Our options start with our Active Directory domain services inside Azure. So this is where we are deploying servers that are running Active Directory as domain controllers inside Azure as virtual machines, as a separate site, a forest, or a domain. And they're connected back to our on-premises environment and our other domain controllers using a VPN connection. We could also use Azure AD Connect. So with Azure AD Connect, we can synchronize those identities from our on-premise Active Directory into Azure Active Directory. And then the resources we've got inside Azure will use Azure Active Directory to authenticate and authorize those user credentials. It means that the login process happens and the Azure resource doesn't have to try and communicate back to a domain controller on-prem to do that authentication and authorization. Now, another option is Azure Active Directory Domain Services. And with Azure ADDS, it's domain controllers as a service, where Azure provides a service that acts like an Active Directory domain, but you don't have any domain controller virtual machines to manage and operate. With this, we can domain join our virtual servers that are sitting inside Azure to our domain. When we're talking about Active Directory domain servers inside our Azure architecture, this diagram shows Contoso.com having a physical branch with their VPN gateway and their standard Active Directory servers. They connect to Azure through their VPN gateway. And then inside the virtual network in Azure, we have these ADDS servers. We're putting them in a separate subnet and we're protecting them with a network security group to provide a firewall to protect against unexpected traffic sources. Now, that gateway connection between the on-prem network and Azure provides the synchronization between the Active Directory servers that we have on premises and the Active Directory servers that we're running in the cloud. With this configuration, you are still responsible for sizing the virtual machines inside Azure for these domain controllers and managing them like you would a standard on-prem AD server. Azure AD Connect is a different architecture because we don't have those domain controller servers anymore inside Azure. Instead, in our on-premises network, we have our standard domain controllers and our clients, but we also have a server that is running the Azure AD Connect sync service. Now, it's responsible for transferring the data between the information inside the domain controller in our on-prem Active Directory into our Azure Active Directory tenant. There are some technical details in terms of password hash sync and password write back and how all that works, but this isn't a pure identity session. So if you'd like some more information on that, check out the information at docs on Azure AD Connect. But just briefly, from a sync perspective, we have this automatic sync going on in the background that keeps up to date with changes in your on-prem Active Directory and synchronizes information through to your Azure Active Directory tenant. Your on-prem Active Directory remains the primary source of authority for creating new user accounts, changing details about those users, for example, and it will synchronize those changes through to Azure AD. It's important to note that that sync is never synchronizing a copy of what the user's password is. It's synchronizing a hash of that password. It's demo time again. So let's say that Tailwind traders have a server, a Windows Server virtual machine sitting inside Azure, and they'd like to be able to sign onto that Azure VM using credentials that are inside their on-prem Active Directory. This demo is going to step through the process of creating a virtual machine and enabling it to be logged into using credentials from Azure Active Directory. Now, this is different to using Azure Active Directory domain services, where we would actually domain join that Windows server to a domain. So this doesn't do that, but it still lets you log in with an Azure AD account. Now, that Azure AD account may have been created inside Azure Active Directory natively, or it might be syncing from an on-premises AD environment. There's some important steps that we need during the creation of this virtual machine. So in the Azure portal, we'll go to virtual machines and we'll add a new VM. We'll put it into an existing resource group. So we have one here called Hybrid VM, and I'll give it a name of Server 02. Now, like any VM, we have to pick a region, but the interesting thing here is which particular operating system that we're going to use. It's important to note that there are only two types of operating systems that this particular scenario will work with, one of them being Windows Server 2019. So it has to be a minimum of that Server 2019 version, or it also works if you're creating a Windows 10 VM. We'll leave the defaults here for size and we'll create an administrator account. Remember, with Azure, you can't use administrator as the username, so we'll call it Prime. And of course, we have to put in a complex password and verify it. Now I'm going to leave port 3389 open. And bonus points if you gasped a little here. It's not a recommended configuration to leave 3389 open on your servers, and you should be restricting network access to that port or leaving that port closed and using something like Azure Bastion for a secure connection. But that's kind of outside the scope of this demo. For now, just to make it easier to connect via RDP to show you some capabilities, we are going to see a few warnings from Microsoft to remind us that opening up port 3389 on this server to the entire internet is probably not the best idea. Then we'll step through the disks and the networking. There's nothing in particular we need to change here, so we'll just leave this at the defaults. And here again for the virtual network and all of these network settings, again, 3389, yes we know. We'll leave it on for this demo. The management tab is where we need to change some settings, and we need to change them when we create this virtual machine. The management tab is where we need to change some settings. Now the review and create box is blue, which means we could go and just create a VM now with all of these defaults set, but there are two particular settings that we need to change in here. If we scroll down first to identity, we need to turn System Assigned Managed Identity on. This provides an identity for this Azure resource, our virtual machine, inside Azure AD, and it can use that identity to obtain Azure Active Directory tokens. And we also need to turn on Login with AAD credentials. I'm going to turn off auto shutdown because I don't want this computer to turn off, and I can leave the rest as the defaults. Finally, in advanced, there's no specific extensions or anything that we need to install, and I'm not going to bother tagging this demo machine. So now it's going to go through the review process and check that all of these settings that we've put in place for this virtual machine that we want to create aren't contradicting any Azure policies that are being enforced in this place where we're creating it. And when that validation has passed, we'll go ahead and create this virtual machine. So it'll go through and create all the required resources for that VM. And then we can go back to our virtual machines pane, and we should see this virtual machine has been created and it's running. Now, let's go take a look at Azure Active Directory. You can see I've got a big list of users here. For testing purposes, I've got Gamma user and Jupiter and Mercury Venus. And if I go and take a look at Jupiter, for example, you can see down the bottom that the source says that this is an Azure Active Directory user. So this account was created natively in Azure AD. Going back to our server, we need to assign some roles. So in the server properties, we want the access control tab. That's where our resource-based access control role assignments are granted. We're going to go and create a role assignment here for the people to log in. Now, the roles that we are looking for are either virtual machine administrator login or virtual machine user login. And the people that you want to be able to log in and have access to the server using their Azure AD credentials need to have one of those two role assignments set in the access control tab on the server that they're logging into. I'm going to do this with an individual user for the purposes of this demonstration, but you could put a group name in here instead and then add the users to that group. So we'll go and save that role for Jupiter. We're giving them virtual machine administrator access, which means that they'll be able to administer that server as part of the server's local admin group. Now remember that adding those role assignments can take up to 30 minutes to apply. So if you go and try and log in to the server straight away and it doesn't work, it might just be that that RBAC assignment has yet to be completed, actually being assigned into the server. I'm going to go ahead and connect via RDP. I've given it some time and sped it up for you, downloading the RDP file and connecting to the server. Now there's a bit of a trick here when you use this connection. When we go connect, we need to click on more choices. The RDP connection has defaulted to the administrator username that we created when we created this VM, but we need to change that and put in a specific format. So we'll choose use a different account, and you just have to be very careful how you format these login details. What you need is Azure AD / as the domain name, and then the full UPN, this unique name of the user's account. In this case, it's jupiter@tailwindtraders.net. And if we put in there Azure AD password and go and log in, it's now going to authenticate with Azure Active Directory for that user, but let me log into this particular server. Remember, we set up Jupiter as being a virtual machine administrator login. So they've got the option in here to shut it down, but we're going to disconnect from this session to leave the server running. Let's go take a look at a different user account. If we go back to Azure Active Directory, and we'll use Mercury Venus. Now with Mercury Venus, you can see that their source is set as Windows Server AD. So we know that this account was initially created in an on-premises environment inside Active Directory from Windows Server, and it has been synchronized into Azure Active Directory. So similar process, we need to go back to our virtual machine into our access control blade. And this time we're going to add a role assignment in here. So we can see we've still got Jupiter, but we're going to add a role assignment for this other user. So we'll also make them a virtual machine administrator login, give them that role, and add Mercury Venus. And once that role has applied, let's go and test the connection with this user. So remember that this user has been synced into Azure Active Directory from an on-prem Active Directory environment. Again, more choices, and we use that particular formatting using a different account with this Azure AD / and then the unique name for this Mercury user. Now it's going to connect and log us in successfully to the server. The virtual machine user login role, they wouldn't be able to shut the server down. They'd only be able to disconnect their session because, of course, we don't want users shutting down the server thinking that they're logging off and shutting it down for everybody. And that's the end of this demo. You've seen the 2 key things you need to change when you set up the virtual machine to enable this functionality, and then how you need to add the role assignments for the people inside Azure AD that you want to be able to log into the server with their Azure AD credentials. And that works whether they're native accounts or they're synced accounts. This session has thrown a lot of complex terms at you because we've looked at both networking and hybrid identity. What we've ended up though is some scenarios where Tailwind traders can use Azure VPN and ExpressRoute to connect their branch offices to those resources and workloads in Azure without making those cloud resources available to the public internet. They've also explored how they can use ExpressRoute to ensure that network traffic from specific offices into specific workloads and resources in Azure doesn't cross the public internet, that network traffic. And they've now established an Azure Virtual WAN. So they've simplified their entire networking topology, both between their offices and the cloud and between their branch offices and each other. And finally, Tailwind Traders has explored how to use Azure AD Connect and Azure AD Domain Services to restrict access to resources and workloads in Azure data centers using the on-premises identities that they already have. If you're interested in delving into the technical aspects of these concepts further, there are some great resources at docs.microsoft.com. I'll leave them here on screen for Azure VPN and ExpressRoute, the Azure Virtual WAN, and the hybrid identity scenarios. Hey, thanks for your time. I hope this has given you some ideas to explore for how to configure your networking and identity options between your on-premises networks and Azure. We've explored solutions to Tailwind traders' requirements for network connectivity to cloud resources and for simplifying networking between their branch offices. You've also learnt about the options for using their on-premises Active Directory identity platform to integrate with Microsoft Azure for authentication and access to their cloud workloads. We will now take a 10-minute break. See everyone back here soon, then we will finish part 1 of our event with Module 3, Hybrid Cloud Applications.
Welcome back from the break. My name is Thomas Maurer. I'm a cloud advocate working at Microsoft. And in this next module, we're going to have a look at hybrid compute workloads. And we're going to have a look how we can leverage Azure management technologies to make our Windows Server on-premises environment even better, and how we can actually manage these workloads. So let's have a look. In this session, we're going to talk about hybrid compute workloads and how companies can take advantage of the cloud in their on-premises environment or in their multi-cloud environment using our hybrid services. For this session, we're going to take advantage of our demonstration company called Tailwind Traders, which actually represents everyone and no one at the same time. And we will run through a couple of demonstration scenarios to show you how Tailwind Traders can make their on-premises environment even better using the cloud. Now, before we actually start and have a look at all these solutions, I quickly want to give you a little bit of background what Tailwind Traders has on requirements and why they are in a hybrid cloud environment. So first of all, Tailwind Traders is already in a hybrid state. They are currently moving workloads to Azure, but some of their workloads need to be on premises, right? There are multiple reasons why these workloads can't be moved to the cloud. They have them running in their local data centers, at their branch offices, factories, or retail stores. And again, these can be scenarios where they have data sovereignty challenges, or networking issues or latency issues, or no network connectivity available to an Azure region, right? So there are reasons why they want to use a hybrid cloud environment. Now, the next thing they want to do actually is they want to take advantage of the Microsoft management tools for their hybrid environment. They want to use a single set of tools for their workloads running in Azure or in multi-cloud environments and also on premises. They don't want to separate all these tools and use different tools depending on where these workloads are running. And we're going to have a look in this session how you can use basically the same tools, the same control plane for your workloads running on premises, in Azure, or even at another cloud provider. So in this session, we're going to have a look at how Tailwind Traders can decide which hybrid management and monitoring tools they should use in their environment. Now, we're going to have a look at some of their example requirements, right? So we're going to go through a couple of different scenarios. So the first one is we're going to have a look how Tailwind Traders can actually manage their Windows Server workloads with a consistent experience across their hybrid cloud environment. We're also going to look how they can apply policies to their compute workloads in a hybrid environment. And we're going to have a look at how Tailwind Traders can simplify the management and maintenance of their on-premises virtualization fabric, as well as how they can make their file servers more efficient, taking advantage of the scale of the cloud. And then also, last but not least, we're going to have a look at backup and disaster recovery strategies for their Windows Server workloads in a hybrid environment. So we're also going to have a look at a couple of different tools and services. And again, just in case of time, we can't hit all of the possibilities we have in Azure and with our Microsoft tooling. However, we will have a look at a couple of different technologies and services. So we're going to start a little bit with Windows Admin Center, which is our new web-based server manager, if you will, and allows us to manage Windows Server as well as, for example, Azure Stack HCI. We're also going to have a look at Azure Arc enabled servers, which lets us connect on-premises servers or servers running at another cloud provider to Azure Resource Manager, so we can take advantage of the Azure control plane and start onboarding Azure management services, such as, for example, monitoring. We then also have a quick look at Azure Stack HCI, which is our hyper-converged infrastructure, and how you can leverage that for your on-premises deployments. We're also going to have a look at Azure FileSync, again, taking advantage of the cloud for our file servers. And at the end, we're going to have a look at Azure Backup and Azure Site Recovery when it comes to our backup and disaster recovery strategies. So let's get started with Windows Admin Center. Windows Admin Center, you can see here a screenshot, is a web-based management console to manage our Windows Server infrastructures as well as clusters, Azure Stack HCI deployments, and so on. Now, this is not something running in Azure. This is something you can download and can install that on premises on your Windows Server or, for example, on your Windows 10 machine. And then it allows you to do remote management of your servers using PowerShell remoting in the background. Now, Windows Admin Center at the same time lets you do a couple of management tasks, like all the regular things you need to do, like device management, event viewer, the new performance monitor, and much, much more. But it is also the gateway to the cloud, right? It allows you easily and simply onboard Azure services like Azure Backup, Azure File Sync, and many, many more to your Windows Server environment. And we're going to have a look at that, and we're going to do most of our onboarding using Windows Admin Center. That said, you can also onboard your Windows Server environment without Windows Admin Center. So if you don't have it in your environment, you can still do that as well. However, Windows Admin Center is free. It's a free download. So if you have Windows Server, you can just go out and download it and then start managing your environment from Windows Admin Center. It then also helps you to do like remote desktop and PowerShell session to the servers you manage. So as I mentioned in the backend, it's using PowerShell remoting to manage these servers. So you can also leverage that. So if there is a tool missing or something like that, you can still go in and just do a PowerShell connection directly from Windows Admin Center. And I mentioned that this is something you can install locally. However, in a new preview, we also allow you to use that directly within the Azure portal. So you can basically go out and if you're having Azure virtual machines, you can use Windows Admin Center directly within the portal as well. Again, that is preview, and we're going to have a look at that later on. So now I mentioned that Windows Admin Center can run locally. So this is our on-premises deployment. So one thing we can do is we can obviously then manage with Windows Admin Center our local servers, right, in our on-premises environment. But then we can also go out and say, hey, we have a couple of Azure machines and we also want to manage these directly from our Windows Admin Center. So we have something called the Azure Network Adapter, which allows us to create a point-to-site VPN connection from our Windows Admin Center to our Azure Virtual Network, and allows us then basically to manage some of our VMs running in Azure. Again, this is great if I don't have a site-to-site VPN or ExpressRoute in place, but I have a couple of machines in Azure I want to securely manage from my local Windows Admin Center instance. We can also install Windows Admin Center in a virtual machine running in Azure, and then basically manage our Azure VMs, or also even go backwards and manage our on-premises machines directly from Windows Admin Center running within Azure using a VPN connection or ExpressRoute, depending on what our setup looks like. So let's have a quick look at the demo of Windows Admin Center. Now here we are in Windows Admin Center, and you can see here it's a web-based UI. You can see in the middle I'm already at the networking tab. On the left side you see all the menu with all our tools and extensions, as we call them. So you can see here I have, for example, device manager, I have events, I have files, firewall settings, local groups and users, PowerShell connections, processes, you name it. And there's much more available here. Now, I can also use that for multiple users, so I need to install it once, and then multiple users can actually connect to that gateway. Now, what I want to show you in this demo is that I can actually create here a Azure Network Adapter. Now, you can already see that this Azure Network Adapter is connected. So I already have a point-to-site VPN connection to my Azure Virtual Network running. And so my Windows Admin Center server actually can connect to that machine. So what I can do here, if I switch back to my management experience, I can see here all my servers and I can add a new connection. So if I click on add, I can then quickly see I have an Azure VM here with a private IP address 10.0.2.4. So I can enter that here. And this will now detect our server. And I can click on add. Again, this is now using a point-to-site VPN connection through Azure to add that server. And if I click on that server, you can see here now I can start managing that server. I get some information here. I get some overview about that server. I can see what operating system it is running. And on the left side, you can see here all the tools I can have. So one thing I want to do here, I want to install a couple of roles and features here. So I'm going to install the DNS server feature. So instead of connecting to the server using RDP, I'm just going to select here that in Server Manager. And then I can also go out and have a look at, for example, other features as well. And you can see here, I can basically go through and install all the feature services and features or roles and features I want to. So I'm also going to install wins because it's wins and not lose. So I can click on install. This will then quickly check all the dependencies as I remember it from Server Manager, and then just click on install, and this will go out and now remotely run the PowerShell commands against my server running in Azure to install the DNS server feature role, as well as the Wins server feature and so on, with all the dependencies. So this will take a couple of minutes, as it would usually take. And after they're successfully installed, I can then go out and have a look at extensions. So we have a preview extensions here for DNS management. So you can see here, this is like basically the extension to manage DNS. So I'm going to install that. And after that's successfully installed, it will reload. And now I can switch back to my server where I just installed the DNS server feature. And now I'm able to use the DNS extension here to actually do my management tasks on that DNS server. So as you can see here, I can now go and create a new DNS zone. So let's create a new primary zone here, call it Tailwind Traders.hybrid. Let's create. And now the zone is created. Now let's do a quick double check. So if I go and have the RTP connected to that server, I can first go to tools, and you can see here I can open up DNS because this is obviously a DNS server. So you can see here the feature at least was installed. If I go to the zones here, you can see here's my primary zone for Tailwind Traders.hybrid. So you can see here that I have a great way of managing servers remotely using Windows Admin Center. And with the Azure Network Adapter feature, I can also easily connect to an Azure Virtual Network and manage my servers from my on-premise Windows Admin Center within Azure, which is pretty cool. So for the next part, I quickly want to talk a little bit about how the Tailwind Traders environment gets increasingly complex, right? So we actually had a look at why their environment gets more and more complex, and we discovered three main reasons why this is happening. And I'm sure this also happens to many, many other companies and even real companies outside in the real world. Now, first of all, IT or IT admins and developers, they need to manage hundreds, if not thousands, of different applications. Some of these applications are modern applications written in modern languages like .NET Core and many others. They're running on PaaS services, serverless, containerized, and so on. However, what we also can see is that obviously we have a lot of traditional applications running on virtual machines or even physical machines, right? And IT needs to take care of all of that. Now, another thing we are seeing is that, and I mentioned that before, there's a very diverse infrastructure, right? So companies have their own local data centers. They have some outsourced to local service providers. They're using branch offices. They have factories. They, in some cases, use different OEM hardware. They have IoT and many, many other things they need to take care of. And usually these end up in having multiple management tools and multiple access tools to manage that infrastructure. And then last but not least, there's also multi-cloud, right? So a lot of companies, or many companies, are in a multi-cloud environment. Even though, for example, they decided to go with Microsoft Azure, there are other companies which already have other cloud providers onboarded, right? So for example, from the past in history, they start with another cloud provider, one department did that, and they're not going to migrate now everything over. Or other companies, for them, it's really a strategy to have multiple cloud providers. But again, this means also that you have need additional management resources, right? Now you're not just dealing with one cloud provider and the tools of one cloud provider. Now you need to deal with multiple of those. And we want to address that to make it easier to manage everything with a single control plane. And we kind of have that. So if we look at Azure, Azure has a very good control plane. So this is a high-level architecture view of our Azure management services. So let's start on the left here. So we as Azure customers, when we interact with Azure, we're using the portal, PowerShell, the Azure CLI, APIs, the SDKs, and so on. And what we are doing is we are interacting with Azure Resource Manager, which is basically the magic behind all the Azure management tools and experience. So what we have there in terms of security or access, when it comes to role-based access controls, logs, subscription management, policies, blueprints, tags, search and indexing, everything you need for inventory or organization, that is basically done by Azure Resource Manager. And then we also offer on top of that a couple of management services for monitoring, update management, backup, disaster recovery, security, and many, many more. And until we announced Azure Arc, Azure Resource Manager and these management services were mostly designed to manage Azure resources, right? So what we did with Azure Arc, we actually extended the Azure control plane with Azure Resource Manager to allow us onboarding services which live outside of Azure, right? So as of today, with Azure Arc, we can onboard servers, Linux and Windows servers. We can onboard Kubernetes clusters and data services to actually take advantage of that single control plane we get within Azure. And we're going to have a look at that, how that looks like right now in this demo. So here I am again back in my Windows Admin Center installation. You can see here all my servers listed. And what I'm going to do here is I'm going to connect a server to the Azure Resource Manager using Azure Arc, the Azure Arc feature. So let's have a quick look. So we're going to select our server 4 here. I'm going to manage that with one of my local credentials here. I'm going to connect. And as you saw before, we can now manage that server. And we could do some management tasks here. However, we will scroll down to settings. And in settings, we can now simply onboard our server to Azure Arc for servers. So what I'm going to do, I'm click on Get Started. I'm then make this a little bit smaller here. I select the right subscription and the right resource group. I want to add that server. I can then also select the Azure region I want to connect that server to. This is only for the metadata connectivity of the Azure Arc agent. And then I can also basically use a proxy server if my server is behind a proxy. So when I click on setup, this will now set up the Azure Arc server. So it will download the Azure Arc for Service agent. It will install that agent and then will register my server with Azure. So when this is done, my server will basically show up in Azure as an Azure resource. So here it's now connected. What I can do right now is I can click on view this server in Azure, open that link. And if I do a quick refresh, you will now see here that I can see here my Azure Arc enabled server I'm just joined. It's now a Azure resource. So I can see it now in the Azure portal. You can see here it looks like an Azure resource. I can do a couple of things. I can do extension management. But let's have a look at one of the features called Insights, which is a monitoring feature. So what we can do here is we can enable Azure Monitor for that server. So I'm going to enable that. This server then needs to be joined to a log analytics workspace. And then I can enable the Azure monitoring feature for that server. Again, this server is running locally here in my own Tailwind Traders data center. This, again, will take a couple of minutes to connect everything to make sure that the agents are installed at the right way and registered to the right log analytics workspace. And after a couple of minutes then, I can now see my server coming up here. So what I want to show you here are a couple of things. So first, let's have a look at performance. So here I get some performance monitoring data. I can see how much disk space there is, CPU utilization of that specific system, memory utilization, if you will. I can see the IOPS and disk throughput of that system, as I can do with Azure Monitor. I also have logical disk latency, percentage used, and then also some network information in terms of how much bandwidth I used with my server. I have a couple of other tools here available as well, and I want to quickly highlight that as well. So another thing is the dependency map. So with the dependency map, you can see here, I can actually see to what services or endpoints is my server connecting to. So I get, for example, the information that my server here is connecting on port 445 to one server here, which is a local server or a local IP running in my own location. However, I can see that for many, many other systems as well. And that really helps me to see, hey, what are the dependencies between the different systems? And why is my server connecting to that? I can then also build security monitoring on that if I want to. And I can get much, much more out of that. Now, Azure Monitor is just one feature which is embedded into Azure Arc enabled servers. And there's much, much more when it comes to that. So this was the Azure Arc enabled servers demo. Let's have a quick look at the architecture here. Now, what we have seen here is that we actually connected our on-premises server. Again, this can be a Linux or Windows server to Azure. And then we onboarded that to the Azure Resource Manager. And then we can onboard services like Azure Monitor, Azure Policies, Update Management, and so on, like we would do with an Azure VM. Now, again, as I mentioned, there's much, much more you can do with Azure Arc enabled servers. And I want to give you a quick key takeaways what we actually can do. So with onboarding servers to Azure Arc, we can actually get an inventory of all of our Windows and Linux servers, physical and virtual machines running in our private data centers or hosted clouds, and it's completely domain agnostic. I can also take advantage of the governance and security tools in Azure, and we're going to show you more in this training as well. So you will be able to use built-in policies to manage Azure and Azure Arc enabled servers. We will take advantage of Azure security centers and security baselines. So you get basically one view to see all of your compliance or your compliance overview. You get role-based access, so you can actually get access to the different servers you want to. And if you're a managed service provider, you can also combine it with Azure Lighthouse. And then last but not least, obviously, by adding that server, you get basically a searchable inventory and experience in the Azure portal, which you can also leverage, by the way, using CLI or PowerShell or whatever you're using to access, like get the data from the Azure from Azure. You can then get through it and see an overview of all your systems. Doesn't matter if they're running in Azure, on premises, or at another cloud provider. And then you can take advantage of tools like, for example, tags to manage these servers and organize these resources. So the next thing I want to talk about is extending the virtualization fabric or modernization of the virtualization fabric of Tailwind Traders. And for that, I want to talk about Azure Stack HCI, which stands for Hyperconverged Infrastructure. Azure Stack HCI is part of our Azure Stack portfolio. And again, Azure Stack is not just a single product or solution anymore. It's now a set or a portfolio of products, if you will, with Azure Stack Hub and Azure Stack Edge. And when it comes to our hyperconverged infrastructure, we have Azure Stack HCI. And Azure Stack HCI offers a couple of different features. And so let me quickly talk about this. First of all, it's our hyperconverged infrastructure stack. It's now we have now a specialized host operating system. It's based on Windows Server, but we took everything out which is not needed for as a hyperconverged infrastructure. So everything is not needed for virtualization, networking, storage. We have taken that out, and we have built in additional new features, like for example, stretched cluster, so you can have an active cluster over multiple regions, faster resync of storage spaces, and then also integrated, for example, full stack updates with our OEMs together, so you can actually go out and run an update over all of it. We also deliver it now as a Azure service. So that means it's natively integrated within Azure. So that means no agent or anything to install. Azure Arc is basically built in to the Azure Stack HCI operating system. And then you can manage it through the Azure portal if you want. You get the great Azure support with a dedicated support team in Azure. And you also get your billing over Azure itself. So we will have an Azure subscription, and that's what basically your billing information goes against it. We also will offer self-service VM creation, so you can then actually go out and create your virtual machines on your local Azure Stack HCI installation directly from the Azure portal with the same experience. And again, think about role-based access and other things which come in very handy when you do that. But this is not a complete new experience. So you can also leverage your existing skills and knowledge you already have of managing Windows Server and your infrastructure. So you can actually go out and customize the hardware of your choice, right? So we have a huge catalog of Azure Stack HCI validated hardware together with our OEMs, where you can pick and choose and build it in the right size you actually need it. From very small 2-node clusters, for example, for your branch offices, up to very high performance 16-node and large scale clusters as well. You can use the familiar tools like Windows Admin Center, System Center, PowerShell, third-party solution like Azure Backup, for example, and you get full access to the Azure Stack HCI, full administrative control over that. If you need to install something or need to change something, you can actually go out and do that. So we want to talk about file servers now. I think everyone got them and everyone needs to manage them, but they have been here for years, but it's time a little bit to modernize them. So I want to give you an example of the Tailwind Traders environment here before I actually go. I'm going to show you a demo here. So first of all, Tailwind Traders has a file server in New York where users and applications are accessing these files. What Tailwind Traders did is they connected that to an Azure file share using Azure FileSync. And that gives them immediately one benefit, and that is cloud tiering. So they can now say, okay, I want to only keep files which are younger than 2 months, for example, on-premises storage. and everything else gets offloaded to the cloud. However, the files still show up on the local file share, but when a user clicks on it, the file will be downloaded from the cloud, so you can actually save some disk space. You also get now cloud access. So instead of, for example, the need of accessing that local file server, users working from home can now access that file share. We also get multi-site sync. So they also want to have the exact same files available in their Seattle office. So they can just add a second server to the Seattle office and synchronize these files over the cloud using Azure File Sync. And while these files are already on this file share, they can take advantage of Azure Backup, which then can just back up that file share. And in case you need to restore something, you can easily do that in Azure. And again, Azure Backup is a great service. We will talk a little bit more about it soon, but it gives you, for example, 99 years of retention, so you can store it for a very, very long time. It's very cost effective, so very great service. And then another scenario here would be rapid file server disaster recovery. So what happens if the file server in Seattle crashes? So usually Tailwind traders would send home all their employees. No one would be able to access that file server anymore, and then would just wait until they set up a new server, they reinstalled everything, and they started to restore all these files. Now with Azure File Sync, they can just basically spin up quickly a new server. Let's say it's called server free. They can go out and install the agent, and the agent will now register again with the Azure file share. It will download the metadata. So in a couple of minutes, all the files will appear again on server free. Now for the user, it looks like all the files are already back. However, when they click on a file again, it will download the file from the file share over the internet in the background. So you don't need to wait until everything is completely restored. You can immediately let users work again. So let's have a look how that can look like in a little bit more advanced architecture. So when we have our on-premises environment on the left and our Azure environment on the right, you can see here I have on-premises, I have a domain controller, and I use Active Directory AD Connect to synchronize my identity with Azure AD. And then on premises, my clients are actually accessing, for example, different file servers. In this case, it can also be just one, but like in many cases, you have multiple file servers in different locations. And what we are doing with Azure File Sync, we are basically synchronizing these with an Azure file share living in Azure. Now, an advantage now is also that now clients which are not in the office, which are not next to a file share, they can now access the Azure file share from wherever they are. Again, if you enable that feature, so you can actually enable them from working from home with that file share. So actually great solution here. So let's have a quick look at the demo here of Azure File Sync. So here I am in Windows Admin Center again, and I already prepared a file server here, which I want to connect to Azure, to an Azure file share using Azure File Sync. So I click on file server 1. And now what I'm going to do is I'm quickly have a look, what files do we have here? So we have a built-in file explorer in Windows Admin Center. And I can see here on the E drive, I can see here I have a folder called Designs with folder A, folder B, folder C, and folder D with a couple of files in it. All right. So you can also have a look at the file share. So you can see here we have a file share called Designs, which I actually share these. And so what I want to do here on file server 2, I want to have the same look I had on file server 1. So here I have a file share called Designs as well. Now if I have a look at the files here, you can see here my E drive again, I have a folder Designs, and you can see here this is empty currently. right? So I don't have any files on file server 2, but I want to have the same files from file server 1 on both file servers available at the same time. So I go back to file server 1, and I'm going to set up Azure FileSync. And again, this wizard will help me to set this up. So I'm going to select the right region for my FileSync. And you can see here, I want to edit the resource group, for example. So I create a new Azure resource group for my file share. I create a new storage sync service, and this will then also go out and create all of these resources. So it creates my Azure resource group, my sync service. It will download the agent for the Azure FileSync and will register that server with Azure. So after that is done, my server is now set up and connected to that sync service. However, I did not sync a folder yet. So I need to go out and select the folder I want to sync. So on my E drive, we now provide the name of that folder. So you can see here it now shows E designs, and then I can enable tiering if I want to, and then I can configure how much space I want to keep free. I then also configure that for a sync group. Give that sync group a name because I want to join the other server to the same sync group. I create a new Azure file share to sync that server, and that means also I need a new storage account. So I'm going to create that, and again, Windows Admin Center does all of that for me. I can do the same thing in Azure without Windows Admin Center, but Windows Admin Center really makes it easy for me to onboard Azure FileSync. So you can now see that we also have that sync set up, and that tiering is enabled, and that folder is actually syncing. So if I go to my Azure portal, if I go to resource groups, you can see here I have my hybrid file share resource group, and I have a couple of stuff in there. I have my sync service as well as my storage account. If I go to my storage account, I have a file share. In that file share, you can now see all the folders with the files I synced from file server 1. So the next thing I want to do is now I want to have the same files, obviously, not just in Azure, but also on my file server 2. So I'm going to set up the same thing on my file server 2. This time we have some small differences because most of the stuff is already created. So it already selected the right resource group, the already existing storage sync service. It installs the agents and registers that server. Now, again, I need to now add which folder should be synced. So I can actually select my folder here and then also say, okay, I want to join that sync group. So let's do E designs. And then again, select the existing sync group this time, the existing storage account, and just set it up. And now it says successfully synced that folder. So if I now go back to the files, you can now see here, I have the same folders available and the same folders and files available on file server 2 as well. So I want to show you one thing here, that all files are available right now. So if I create a new folder, I can create folder E. And now that folder is created. There's obviously nothing in there. But let's create another folder here called subfolder, just so you see that there's no issues. So let's go back to Windows Admin Center. And now we go to file server 1. And now we want to see if the same folder is now on server 1 as well. So I'm going to my file share drive. And now you can see here, I have folder E now also available on file server 1. So this is a great sync. We're basically now syncing these files and folders over Azure between different servers. And so we always have the same files and folders available on all of our locations of Tailwind traders. So the next thing I want to talk about is Azure Backup. Now, Azure Backup is a great quick win for Tailwind traders environment. So what it allows us to do is actually simply not just backup and restore services in Azure, but also do that in a hybrid environment. It basically automatically allocates and manages the backup storage in the background, so you don't need to take care of that. You don't need to add more storage to the backup pool and stuff like that. You basically have unlimited scale available with local redundant storage and geo-redundant storage. Again, depending on your requirements, you can choose which one works better for you, or what are your requirements. And this also obviously depends on the price you want to spend. And then there is no charge, by the way, for data when you need to restore, right? So you obviously, if you're familiar with Azure, usually ingoing traffic to Azure is free, and then outgoing traffic to Azure, there's some cost involved. We don't want to charge you if you restore a backup, right? So we don't do that in terms of when it comes to Azure Backup. And you have a pay-as-you-use model, right? So you only pay for the things you actually need and not for the storage. You don't need to pre-reserve storage or anything like that. You can just pay, and as soon as your storage grows, you obviously will also pay more automatically. Everything is encrypted. So when it comes to like data in transit from your on-premises machine to Azure, this is encrypted. Your on-premises to Azure Backup, the data in Azure, which is encrypted at rest with a key phrase we will set up when you set up the backup, and we will show you that in a quick demo. So you bring basically your own key phrase. And then for Azure VMs, for example, the data is encrypted at rest using the storage service encryption. Now, I also want to say there are some other features and properties with Azure Backup. So you have, for example, an application consistent backup. You have no limited amount of time data is stored in your recovery vault. You have a limit of 9,999 recovery points per protected instance. And then you have multiple options depending on what you need when it comes to Azure Backup, right? So for example, you have the Azure Backup agent, which you can actually go out and just install an agent on a Windows 10 machine or on a Windows server and then back that up. If you need to, for example, back up multiple systems or also applications, we have also something called the Azure Backup Server, which you can basically download and install for free on premises. And then you can do a short-term backup on that backup server and then offload the long-term backup to Azure. Azure Backup is also the service which basically backs up your Azure infrastructure as a service virtual machines, including, for example, SQL and Windows IaaS VMs. And then, as I mentioned before, it also can back up your Azure file shares as well. There's also more. So if you, for example, look at Azure Backup Server, it can back up and restore VMware VMs as well, Windows and Linux. Again, same thing, by the way, for Hyper-V VMs. You can back up files, folders, volumes, VMs applications like Exchange or SQL or SharePoint. And you can also back up like the system states of servers as well. It then backups basically to local attached disks for short-term storage. So if you need to back it up and then quickly restore it, you can do that directly without anything. But then for the long-term storage or also off-site storage, if you will, we have the Recovery Service Vault in Azure. Also mention quickly, because we get these questions a lot, it also does application-aware snapshots using VSS. It's full flexibility for when to take the backups. You can completely configure that yourself. And you can also have a recovery granularity depending on what you actually want to recover. Now, if we look at an Azure Backup architecture, what we can see here, for example, we have an on-premises environment We have a couple of workload servers like SQL, SharePoint, Exchange, file servers, and domain controllers. And then what we did here in this scenario, we installed a Azure Backup server, which will actually back up these workloads. And then you can send them through Azure, again, over the internet or over ExpressRoute, or use even the Azure import and export service to actually, like when you have a big chunk of data you want to move, you can, for example, also leverage that as well. And then this will be stored basically in the Azure Recovery Vault, which will manage the storage in the background. We use Azure Storage for that. And then you can also replicate that to a secondary Azure region to make that like disaster recovery basically enabled if one of the Azure regions should go down. So let's have a quick look at Azure Backup. So here I'm back in Windows Admin Center. And what I want to do here is I want to back up the files on one of my servers here. So as you can see here, I click on my file server 1, which we used before. So if I quickly have a look at the files on that server, I can see here that I have my E drive. I now have a folder called Research. And in that folder, again, I have folder A, folder B, folder C, folder D. And now I want to configure Azure Backup to actually back up the folders and the files on that machine. So what I can do here is I can simply click on Setup Azure Backup. And this will then go out and ask me for my user account. It will also set up the Azure Backup for me. And then it will ask me, what do I want to back up? Now, in my case, I just want to back up the files on my E drive. And then here I can go out and I can select the retention rate and the schedules basically of the backup. So in this case, very simply, I select one of the pre-configured ones, daily, retain 30 days. And then I can enter my passphrase, my personal one I want to create. This is very important. If I need to restore files, I will need that passphrase. So make sure you save that at a secure location, because we can't help you restoring that. So now it sets up Azure Backup. It will install the backup agent in this case, and then will automatically configure the backup as I configure that. Now, it's obviously going out at a specific schedule, but I can also trigger the backup. So I'm going to trigger the backup to create a recovery point right now. This will start the backup and will take a couple of minutes to complete, especially because this is the initial backup. So on the jobs, I can actually see what is going on here. So if I refresh, you can see that at the moment, data is now transferred, and basically the backup is now completed. So I have now one recovery point basically of these files. So if I click on that, you can see here when this recovery point was created. And again, I can do that for multiple times, obviously. Now I go back to my files here. And what I'm going to do here in my research folder, I'm just going to now accidentally delete folder D. So folder D is now deleted with all the files in there. Now let's switch back to my server to actually show you that. So I'm here on that server. And if I go to my E drive, you can see here I have my folders research. And again, you can see folder D is gone. Now I want to restore that. I can simply open up the Azure Backup console here. And you can see here, I can find the same information here. And now I can click on recover data. I can say, okay, I want to recover from this server, just files and folders. So I don't want a whole drive. I just want to have some files from that. You can see here, it was bold marked my last recovery point. You can also have, again, if you have multiple of these will show. And now it will basically open up that recovery point and mount it. And now I can go and see that mounted recovery point. So if I click on it, you can see here folder D is now here in this recovery point. So I can do a copy and then simply go to my server, go to research, and then basically just go and paste folder D back. And so my folder D is now restored, I can also unmount the recovery folder or the recovery mount point, and my files are available again. So this was Azure Backup. Again, there are multiple scenarios you can use that. However, there is even more. So we can also leverage this, Azure Site Recovery for disaster recovery. So what we can do here is we can actually replicate physical and virtual machines running on Hyper-V and VMware to Azure to then actually have a failover region basically available. So in this scenario, I'm going to show you here with Azure Site Recovery. You can see on the left side, I have my on-premises environment, which is basically, for example, in this case, a web app. So we have a IaaS web server and we have a database server, and we use Azure Site Recovery here to replicate it through Azure. And in case of a disaster, we can then go and fail over our virtual machines to Azure. So in this case, you can see on the right side, it would then have my web server and my SQL server restoring or recovering in Azure. And if we then have a service in front of it called, like, for example, Traffic Manager or Front Door, or depending on your architecture and your scenario, in this scenario, we would have, for example, Traffic Manager. We would just basically switch the routing, the DNS routing, from the location from our on-premises primary side to our Azure failover side, and the application would be available for the end users again. So absolutely great service. So let's go into a quick summary. So what we have seen so far is how Tailwind traders can use Windows Admin Center to consistently manage Windows Server workloads in a hybrid cloud environment. So you can take advantage of Windows Admin Center. You can basically go out and use that today. Even if you're not working with Azure, Windows Admin Center is a great management tool for Windows Server. We also saw how Tailwind traders can take advantage with Azure Arc and basically connect servers to the Azure control plane with Azure Resource Manager and manage them if they're running in Azure, on premises, or even at other cloud providers. We also had a quick look at Azure Stack HCI, our hyper-converged infrastructure solutions, which is a great solution if you do virtualization in your own data center. We had a look how Tailwind traders can make their file servers more efficient using Azure FileSync. And then we had a look at how Tailwind traders can take advantage of the cloud for the disaster recovery strategy using Azure Backup and Azure Site Recovery. So here are some additional resources. So again, I spoke about Windows Admin Center. I spoke about Azure Arc enabled servers, Azure Stack HCI, Azure FileSync, Azure Backup, and Azure Site Recovery. So we put all the links here together for you. So you have aka.ms, and then depending on the technology you want to have a look at. You can also follow our team, so make sure you check out itopstalk.com. You can also follow us on Twitter on itopstalk. So this concludes part 1. So let's have a quick recap on what we have learned so far. First, we had an overview about hybrid cloud computing. Then we actually had a look at hybrid networking and how you can connect your on-premises environment to Azure using site-to-site VPN, ExpressRoute, and much, much more. In the third module, we have learned how we can leverage Azure management technologies to manage our hybrid compute workloads. So thank you for your attendance of this first part, and we're looking forward to have you in the second part of our Microsoft Virtual Training Day implementing hybrid infrastructure.